is it working? Yes, it is. Hey, there we go. Captions, that's good. Okay. So yes. So oxidation we're skipping. Let's do some practice with sorry, hold on. There we go. Very hectic. Pal will become less hectic eventually. It's been very hectic for the last three weeks or so. Okay, so this is redox reactions. I just told you that, but there is a way for you to check if they are redox reactions. But you'll get practice with that eventually. So basically what I want you to do with this stuff is I want you to tell me what is being what is being reduced and what is being oxidized. And then I want you to tell me what like the reducing agent and the oxidizing agent is. So I'll do this example first just to kind of give you an idea, since this one you've probably seen already. So we know there's a saying that you probably heard before. Leo the lion says grr. So that's like I would forget what the word is, but it's it essentially means loss electrons oxidation, gain electrons reduction. So that's all you have to remember to try to distinguish between trying to find the oxidizing, what is oxidizing, and trying to find what is reducing. So just remember, Leon the lion says grr. You probably maybe already have that memorized. But for an example, let's look at this. So we have our zinc, and it's reacting with copper. And this one's pretty obvious. You can kind of plainly see the exchange in charge. Like this copper here has a 2+, and then on the other side, the zinc has gained the 2+. So obviously something has happened with the charge here, but they aren't always very obvious like that. So let's look at the zincs. The zinc originally has a 0 oxidation state. It's neutral, and it becomes a 2+ oxidation state. All right. But that's already written for you. But what does that mean? How did that zinc gain the 2+? Anybody want to tell me?
It took it from the copper.
Right, sort of. But what does like a plus mean? Like if something has a plus
it
charge.
lost the 2 electrons. So.
Yeah, exactly. Zinc was oxidized. Cool. Yeah, exactly. So yeah, perfect. Zinc lost 2 electrons, meaning it has a 2+. So this is a loss of electrons. Perfect. And that means it is oxidized. And so that means for the copper here, so you were right. I was just tweaking kind of your language a little bit. So thank you for answering. So for this one, you get 2+ and it goes to neutral. So that means it's gained 2 negative charge, right? To make it neutral. So it's gained electrons, which is reduction. And that means that, let me use a different color. We say that zinc is the reducing agent and copper is the oxidizing agent, which is kind of confusing because it's opposite to what it actually, like zinc is being oxidized, we call it the reducing agent, and that word agent is really important because it essentially just means that zinc caused the reduction of copper and copper caused the oxidization of zinc. It's kind of a confusing way to name them. But just remember, for the agent, it's opposite from what it actually is. And it helps more with practice too. But since zinc is oxidized, it means it's the reducing agent, and copper is reduced, so that means it's the oxidizing agent. It causes the oxidation. So hopefully that makes sense. I'm going over things quite quickly because we kind of already lost time. But if this is in any way confusing, I'll probably go over it again during the review, and Kirsten will too. So, and you can always ask questions at the end or message me on Teams or anything. So hopefully I'm not confusing you. Reducing. So how about you guys try be yourself and let me know. Well, I'll give you a few minutes to try it. And then somebody hopefully can give me an answer. Shouldn't take too long, so maybe just a minute. It's really good to try the questions because it's good to get it wrong now rather than on the test or something like that. Or get it right. Okay, that was about a minute. Does anybody want to answer? I'm just going to erase this stuff because it's getting a little messy. Just keep the reducing and the oxidizing agent.
The oxygen is reduced and magnesium is oxidized.
So oxygen is reduced and magnesium is oxidized. Great. How did you know that?
Because both of them have an oxidation state of 0 first. And then O has a -2 when it's an MgO. And Mg has a +2 because that's like the priority in the rules.
Exactly. Perfect. Perfect. Yeah, great. So I'll just repeat again. So we just look at the magnesium, like she said, or they said here, it's a 0 charge, and this one's also 0 charge. And you might think, well, O2 wouldn't that have a charge? But since it's diatomic, it wouldn't have a charge, right? We don't say the diatomics have a charge, because that would mean that like one oxygen would have to be positive, one would have to be negative, but we just don't worry about that. Diatomics are 0 charge, right? Hopefully I'm right in saying that. I think that's correct. I'm going to say it is. There we go. And then we look over on this side, and here they're in a compound together, so they're going to have magnesium will have a +2 charge, oxygen will have a -2 charge, and they knew that because one of the rules for oxidation states is that oxygen will almost always be -2, besides in very few compounds, which you can memorize. So yeah, perfect. So that means this would have to be a 2+. So magnesium has lost electrons, so it's oxidized. Oxygen has gained electrons because it becomes more negative, so it's reduced, right? So which one would be the oxidizing agent? Which one would be the reducing agent? Someone wants to yell it out.
Mg is reducing agent and oxygen's oxidizing agent.
Perfect. Exactly. Great job. All right, so again, do the next one. This bad boy right there. And just figure out which one is being reduced, which one's being oxidized, and so on. So I will give you another minute to do so. Should have got water or tea. I usually have tea for these, but I forgot to. Sometimes I wish I could play music. I feel like that would be distracting. It's kind of weird to just sit here in silence. Okay, that was about a minute. Has anyone figured out the answer? Preferably someone who hasn't already answered, even though I really appreciate people answering. But you know, maybe someone else can give it a go, take some pressure off. Anybody got the answer? Someone's gotta. Oh, here we go. Chlorine is being oxidized and oxygen is being reduced. HCl is the reducing agent and oxygen is the oxidizing agent. Great, perfect. And I won't ask you to explain because I'll assume you've used the same logic we've been using. So yes, we look at hydrogen here. I suppose hydrogen could. No, it couldn't. Hydrogen doesn't really take part in any sort of redox reactions because hydrogen really likes to be, it doesn't like to change its charge much or give up its one electron or one proton. Well, it doesn't give up the proton, but it doesn't like to give up its one electron. So it doesn't really, you don't have to worry about that often or at all. I don't think at all. So we just ignore hydrogen, we'll look at the chlorine. So here chlorine is a charge of 0 and here chlorine is a charge of 1, or negative 1, sorry. So, and we know that because hydrogen's always plus, almost always. And so chlorine would have to be negative. There's also oxidation state rules and stuff. So that means it has lost 1 electron, so it's being oxidized. And here oxygen is a state of 0, the diatomic, and oxygen here is negative 2, so it's gained electrons, and that means it is being reduced. And this would be the HCl is the reducing agent, and O2 is the oxidizing agent. All right, perfect. Great job, everyone. Hopefully that is okay doing that sort of stuff. You'll definitely probably have to do that on the test, but with some practice, it's not super hard. And it also combines having to look at oxidation states, so make sure you have oxidation states down as well. Memorize those rules is really important. Okay, so I guess we'll move on. If anybody has any questions, please stop me. Please yell at me if you have any questions at all. But we'll move on to kind of practicing balancing redox reactions, which is kind of the difficult part of this section on redox, right? I feel like it can be kind of hard to balance and remember all the steps. So I've got two examples to go over. Balancing redox reactions. Okay, so let me write this one down. IO2Cl2. I2HClO. Got it. I2 plus HClO. Let me see if anything has a charge. That has a charge. Okay. So I might just I don't know if I have time to, maybe I'll do this one now and then you guys can try out the next one. Just because I don't think we have time for me to let you guys try both of them. So I'll do this one and then you guys can give the second one a go on your own and then tell me your answers. Hopefully that sounds good. Let me just make sure I have everything. I2, yep, okay. So balancing redox reactions, there's steps. Step 1, separate the ox and reduction. So that just means pitting them into half reactions, right? So first step, let me figure out which one's actually being oxidized and which one's being reduced. So if we look at here, we have an O2. I'm just going to write down all the oxidation states first of everything. Oh God, already something. So let's write down the oxidation states in yellow. So O2 is -2. And so that means that since there's 2 of them, oxygen gives off, or totals -4. And so since the total, this is a negative, the whole molecule is negatively charged, this has to be a +3, right? And please stop me if I make, no, that's not right. No, that's right. Yeah, that's good. Please stop me if I make any mistakes. You don't think you did this stuff? You didn't, oh, you didn't do this stuff? You know, when you have to like add in, you didn't do any of that? Let me check. Really? I feel like that's a big part of this subject. Lecture slides. I asked Dr. Reason and said we won't be doing them now. Oh, okay. Shoot. Well then, oh, thanks for telling me, guys. I guess we don't have to do this right now. So, I guess we can just do the limiting reagent question. Shoot. I kind of like doing these. Kind of sucks. They're kind of fun to do. Like, I find it really satisfying. But okay, we'll do them later. That's all right. You don't got to know that. So completely erase that from your mind. Everything I just said. Not everything. Most things. Okay, that's really good to know. Okay, what should I do now? Limiting reagent stuff and percent yield. Let's do that. KO2 plus H2O yields O2 KOH. Makes sense. I'm glad I put this question then. We could have just been lost. Okay, so here is a reaction. So it's kind of like stoichiometry. Oh God, can I spell stoichiometry? Stoichiometry. Guys, I'm not very good at spelling. Just ignore that if that's completely wrong. Oh yeah, wait, I'm missing an O. There we go. I got it right. We're good. So first question is this balanced? And this is a question that you wouldn't be asked on a test. That's a question that you should always ask yourself, no matter what. If you're given a chemical equation on a test, please ask yourself if it's balanced. So is this balanced? No, it's not balanced. Correct. How do we balance it? And if you're still confused on balancing chemical equations, if you check the video from last week, I think it was, I did a bunch of balancing equations that I think are really good. So you should go over those if you're still not sure on how to balance. Welcome, Cameron. I'm sorry that it's so late, but we got some technical issues, so we started late. But does anybody have this balanced? What are the coefficients?
Why does O have a subscript of 2?
Where? Like
With the K.
here?
Potassium. Yeah.
I think that's how it's supposed to be. Potassium might be like KO2. Maybe it's not.
K2O, right?
Oh, it might be that. Because, yeah, that would make more sense, wouldn't it? Man, that's weird. Why did I have it like that? I've been using that question since like last year too. Never noticed. Well, that was a great catch. That was awesome. That was such a great catch. That was like, that was great. Man, I'm impressed. Yes, it should be K2O. That's awesome. Yeah, great job, everyone who caught that. Very I like that you're thinking about that. That was great. But yeah, does anybody have the coefficients for this? Yeah, that'll probably help with this, huh? Give you guys a second to balance it out. Now that the number is correct. Anybody? I'm not sure how long I should wait, but hopefully people are balancing this equation. Is it kind of hard to balance? I don't know. Let me see. This reaction might be messed up now. Let me see. It's 2K, 1K. Put a 2 here, right? And then there's so many oxygens. Now there's 4 hydrogen. So multiply here. So now we have 4 hydrogen, right? And now we have 1. So we need to multiply this by 1/2. Okay, I guess I'm just balancing it now. Okay, so to balance, I multiplied this by 2, the KOH, because you just start with, the rule for balancing is start with the other, anything that isn't oxygen or hydrogen, and leave oxygen and hydrogen until the end. So I start here with a 2. So I have 2 potassium on each side. And so then I balance the hydrogen because it shows up less than the oxygen does. So I balance the hydrogen. So I have 2 over here. Wait, why did I write 4? What did I write 4? We have 2 over here and 2 over here, so it's balanced. And now I have 2 oxygen and 3 oxygen, so I need to multiply this by 1/2. And then 2, right? I'm not making a mistake here, right? 2, and then multiply this by 1/2 gives you 3, and then 3 on this side, 2 and 2 and 2 and 2. Yeah, so that would be balanced. So this little half here is like a trick. You can use fractions to sort of balance different things. Again, if you want to go look at the video from last week for balancing equations, it could, I think it's really good. I mean, yeah. So if you're still confused on balancing equations, yeah, look at that. But so now to get rid of this half, because you don't like halves in normal chemical equations unless it's half reaction, but you'll get into half reactions later. So now to get rid of this half, I multiply everything by 2. So my final chemical equation is 2O plus 2H2O yields O2, and then 4KOH. And someone, I think that should be okay, right? 2, 2, 4. Yeah, 4. No, why is this still wrong? Hold on. Let me restart. Oops. Should be like that. Okay, wait, so we have 2 here. I multiply this by 2. So now I have 4 oxygen on this side and only 2 on this side. So I multiply this by, I need to essentially get rid of that. Not 1/4. That would give me 1/2. Yeah, no. Is this equation messed up now because of that? It might be messed up now. Okay, let me make a new equation. I think I messed it up with that mistake. And for some reason it's not balancing. Let me make up a new equation. Let's just do find one here. Sure. CH4. Cl2. That's probably why you guys weren't answering me. CCl2 plus HCl. Okay, now we can balance this one. Make sure I wrote it all correctly. Yes. Everything is good. No, this should be 4. There we go. Sorry about that, guys. Who would have thunk? Okay. So now let's see here. We have our carbon. Carbon is balanced. We have Cl2. So this should be 2 because there's 4 on this side. Oh, wait, no, there's a HCl. So I should, there's 5 on this side, so I should multiply this by 5/2. Right? 5, right? And then what about, this should be 4. So let's get rid of this now. There's 4 hydrogen, so 4 hydrogen. So now there's 8 Cl2, and I can multiply this by 4. And then everything is balanced. 1 to 1. This is 8. And then we have 8. 4 hydrogen, 4 hydrogen. Okay, now everything is good. There. Crisis averted. So it is balanced now. Great. We got through the first question. So let's say I have B. 35 grams of CH4 and then 25 grams of Cl2. And the question is, what is the relimiting reactant? That is the question. Hopefully everyone's still paying attention. So go ahead and give that a try. 4 and 4. I'm just making sure I didn't make any. Yeah, no, that's good. That's balanced. So I'll probably give you what? It's kind of a long calculation. Couple of minutes. And if you guys just want to raise your hand once you have the answer, that would actually be really helpful. I won't call on you to answer, but just raising your hand lets me know that you finished the question. So yeah, just click the raise your hand button once you've finished. Okay, we've got someone finished. That's great. Couple people. It's not a race though. Pop, pop, pop. Nice, nice, nice. I think CO2, or sorry, not CO2, potassium dioxide, KO2. It's called potassium superoxide. And I think it's just, it's a case where oxygen is -1. So everybody's done. So CO2 or KO2 does exist. It just means the oxygen is negative. It's 2 plus, it must be 2 plus. Anyways, it does exist somehow, at least that's what Google says. But it must not be very stable. All right, everybody's done. Does anybody want to walk me through their process? You can all, here, I think I can raise your hands. If nobody wants to, that's okay, but if someone does, that would be awesome. Anybody? Cool, no. So first step, you want to take the grams and put them into moles, right? That's the first step. You want to put each of them into moles. Again, please stop me if I make a mistake anywhere. It's been about a year since I've done one of these because I didn't get to try these questions on my own before this session. So first up, we put grams into moles. To do that, we put what we want on top, what we have on bottom. So we need the molar mass, which will be around 16, right? And Cl2, I don't know the molar mass of Cl. I think it's like 60. It'll be for around, I don't know, I'm gonna not guess molar masses. Or no, maybe it's 30. So we put those into moles, right? Does anybody have those numbers at least? That they can read off to me? Someone's got it. You did the question, right? Is something like terribly wrong with this question? Is something like incorrect? Or are you guys just not feeling it? Oh, we got some people in the chat. Because if there's something wrong with the question, just let me know, but I think we should be okay. That's usually when people don't talk to me. We got 2.18 mole of CH4. Fantastic. And we got some thumbs up in the chat for that too. Great job. I was writing these on the wrong. This should just be 1 and 1. That might have confused people. Sorry about that. What was it? 0.35. Awesome. All right, so now what do we do is once we have the moles, right? Now you do a little switcheroo, right? You divide something by something. Right? What do we get? We've got 2 minutes. We probably won't get to finish this question.
We divide the moles by the we divide 0.35 by 4 and the other one by 1 because that's their mole ratio. And the smaller number would be the limiting reactant.
Perfect. Yeah, exactly. That was great. Great explanation. So yeah, this is a little trick. This number that you get from doing this, literally, it means nothing else. So don't ever use this number for anything else. But by dividing them each by the coefficients, it gives you a 1-to-1 ratio. That should be the other way around. So it tells you sort of which one should be run out first. Right, so since this one's smaller than this one, this would be the limiting reactant, sorry. Right? Hopefully that step is something everybody remembered. So now we know that Cl2 is the limiting reactant. Great. Cool. So the continuation of this question was supposed to go through percent yield and all that too, because you guys know percent yield. So if anybody has any questions about that step, just let me know. But there's also percent yield, which is equal to actual yield over theoretical yield, where actual yield is something you find in an experiment, and theoretical yield is something you find through doing math. It's something you'll probably have to do if you're doing any of the labs or anything like that. But yeah, we are out of time, unfortunately. Since we started late, I do have to go. I have many assignments to do, unfortunately. But I hope this helped in any way. And again, if you are confused or anything like that, please just message me on Teams, and I will either help you or add it into the review if you can come to the review. But yeah, thank you guys